3.4 Part 2, Sketching Graphs. Let's first go over the sign chart activity. So to begin, we must realize that this graph is the graph of f. And our first task is to draw sign charts for both f prime and f double prime. So looking at f prime, we know that we have to look at the increasing and decreasing movement. And for f double prime, we have to look at concavity. Is it concave up or concave down on the interval? So to begin, let's first split up the graph where it goes from decreasing to increasing, which is at the point negative 1.5, negative 3. And let's make that interval negative because the graph is decreasing. Now the graph is increasing up until the point 0, 0, so we can make that interval positive. And next, the graph is decreasing until the point 1.5, negative 3, so we can make that interval negative because it's decreasing. And finally, the graph is increasing from there, so we can make the rest of the interval positive. And that is for the f prime sign chart. Now let's move on to the f double prime sign chart. We know that the graph is concave up until a certain point, so we can split up the graph right there. And we can make that positive because the graph is concave up. Next, we can see that the graph is concave down up until the point 1, negative 1, so let's put a negative within that interval. And finally, the graph is concave up for the rest of the function, so we can make the rest of the interval positive. And that is for the f double prime graph. Now we must find the maxima and minima of the graph of f. To do that, we can use the f prime sign chart, because from the sign chart we can see that the graph is first decreasing, then increasing, then decreasing, and then finally increasing. Therefore, we know that there must be a maximum when the graph goes from increasing to decreasing, or positive to negative. And that point is at 0, 0. Moving on, we can say that there is a minimum when the graph goes from decreasing to increasing, or positive to negative, and that occurs at 2 points on the graph. In this case, those 2 points are at negative 1.5, negative 3, and at 1.5, negative 3. And that is our answer for the second part of this problem. Now for the third part, we must find the points of inflection. The points of inflection we know are found from changes within the concavity, or changes within the sign of f double prime, and that happens at 2 points on the graph. So therefore, we can say that our points of inflection are at the point negative 1, negative 1, and at the point 1, negative 1. And that is our answer. Alright, moving on, this time we are given a graph of f prime instead of just f. So our first task is to find the sign charts for both f prime and for f double prime. The process is a bit different this time. In this case, we have to look at the f prime graph. To find the f prime sign chart, we have to look at whether or not the graph is positive or negative. And in the case of f double prime, we have to see if the graph is increasing or decreasing. So let's begin. For the interval from negative infinity to negative 3, the graph is positive. So we can see that that interval must be positive. Moving on, the graph is negative up until 0, 0, so we can make that interval negative. And the graph stays negative from 0, 0 to 3, 0, so we can make that whole interval negative as well. Finally, the graph remains positive for the rest of the graph. Now, moving on to the f double prime sign chart, we can see that the graph is decreasing from negative infinity to negative 1.5, so we can make a box and make that box negative because the graph is decreasing. Finally, after that, we can see that the graph is increasing up until the point 0, 0, so we can make that interval positive. After that, the graph is decreasing up until x equals positive 1.5, I'm sorry. So that makes it a negative. And finally, the graph is increasing for the rest of it. So the rest of the interval is positive. And that is the f double prime sign chart. Now our next task is to find the relative minima and relative maxima of f, not of f prime. So we can see from the f prime sign chart that the graph goes from increasing to decreasing, and then finally to increasing. Therefore, we know that there is a maximum when the graph goes from increasing to decreasing at x equals -3, and there is a minimum when the graph goes from decreasing to increasing, or negative to positive, at x equals 3. So therefore, we can say that the minimum is at x equals 3. Note that at x equals 0, there is a plateau because the graph goes decreasing and then remains decreasing. It does not change from increasing to decreasing. Now our next step is to find the points of inflection. The points of inflection are where the concavity changes. So we know that on this graph, the concavity is concave down, then concave up, then concave down, and then finally concave up. So we know that the concavity changes at 3 points on this graph, at the x values of -1.5, at the x value of 0, and the x value of 1.5. So the points of inflection are x equals -1.5, x equals 0, and x equals 1.5. And that's our answer. Alright, for this problem, let's go a bit overboard and actually draw out the f graph that we can interpret from this graph of f prime. So I've already split it up at the critical values and at the points of inflection. So first, we note the graph is increasing and then decreasing while being concave down. So we can draw the graph like this, increasing and then decreasing. Then after that, we can see that the graph is still decreasing, but it changes to concave up, making our graph look like this. The graph remains decreasing, however, it goes concave down. Therefore, we must make the graph like this. After that, the graph is decreasing still, but it's concave up, making it look like this, and then finally it ends with increasing and concave up. So that's our graph. Alright, now for the third part of this problem, we are given the graph of f double prime. So our first task is to create a sign chart for just f double prime. Note that we cannot create sign charts for f prime and f just based on the f double prime graph. So let's begin. So we have to create a sign chart based on the sign of f double prime. So therefore we can see that it's positive from -infinity to -3, and then it becomes negative from -3 to 0, and then at 0 it becomes negative again from 0 to 3, and then finally from 3 to infinity it's positive. So that is our sign chart for f double prime. Now the next step is to find the x values of all points of inflection of f. So in this case, the points of inflection are where the concavity changes. We know that f double prime from the sign chart goes from concave up to concave down once again, and then finally to concave up. Therefore, from that sign chart, we can tell that there are points of inflection where the concavity changes at x equals -3 and at x equals 3. Note that x equals 0 is not a point of inflection because there is no concavity change. It simply goes from concave down to concave down. So that's our answer. Let's begin this next worksheet where we have to sketch f given the graph of f prime. So as we can see, we are given the graph of f prime, which means that we have to first make sign charts for both f prime and for f double prime to find patterns of increasing and decreasing and intervals of concavity. So we know that to find f prime, we must look at the patterns of positive and negative intervals, while for f double prime, we must look at increasing and decreasing intervals. So for this first example, we can first make a sign chart for f prime. So first, the graph is positive in the interval from negative infinity to negative 4. So that makes it a positive interval. Then the graph is negative. Then the graph becomes positive once again until x equals 1, and then it remains negative until it reaches infinity. So based on this sign chart, we can say that the graph of f is first increasing, then decreasing, then increasing, and then finally decreasing again. Now, moving on to the sign chart for f double prime, we have to look at the patterns of increasing and decreasing. So first, the graph is decreasing up until a certain point. So therefore, we can say that the graph is at a negative interval for f double prime. Next, the graph is increasing until x equals 0, so that interval is positive. Finally, the graph decreases for the rest of the interval until infinity, so that is a negative interval. Therefore, based on the f double prime sign chart, the graph is first concave down, then concave up, and then finally concave down for the rest of the graph. Now, let's move on to actually drawing the graph. I've already pre-drawn the points where there are maxima and minima and changes in concavity. So first we can see that the graph goes from increasing to decreasing and it's concave down. And then after that, we can see that the graph, while still decreasing, is also concave up, so we must draw accordingly. Then finally, the graph is still concave up, but it's increasing this time, so we must make the graph concave up and increasing. Then the graph changes from concave up to concave down, but it's still increasing, so we can draw it concave up, and finally the graph is decreasing and concave down. So that's our graph. For the second example, we must also draw an f prime sign chart. So we can see that the graph is first negative up until x equals negative 3. Then it becomes positive up until x equals negative 1. Then it remains negative until it hits a 0 at x equals 1, and then it becomes negative once again up until x equals 3. After that, the graph remains positive until infinity. Now, let's analyze this sign chart to give us patterns of increasing and decreasing for the function of f. So first the graph is negative, meaning it's decreasing, and then it goes to increasing, then decreasing once again, and then finally increasing. Now let's move on to f double prime. For that, we have to look at the patterns of increasing and decreasing. So first, the graph is increasing up until this maximum, so you can say that the interval is positive. After that, the graph is decreasing up until x equals 0, which makes it negative. Then the graph goes to increasing at this 0, making that a positive interval. Then it decreases once again to give us a negative interval. And finally, the graph remains increasing until infinity. So that tells us about the concavity of f. Therefore, f is first concave up, then concave down, then concave up once again, then concave down, and finally concave up. So now let's actually get to drawing the graph of f. I've already split the graph at the extrema, or critical values, and points of inflection. So we know that first the graph goes from decreasing to increasing while it's concave up. Therefore, the graph must look like this. Therefore, the graph begins like this.
After that, the graph remains increasing, but then it changes to concave down. So we have to change the graph to look like this. Then the graph remains concave down, but goes decreasing, so we have to simply make it decreasing. Then the graph remains decreasing, but goes concave up, giving us a graph that looks like this. Then the graph remains decreasing once again, but goes concave down, making the graph look like this.
It goes concave down, so like that.
Then the graph remains decreasing once again, but goes concave up, and then finally goes increasing for the rest of the graph, making the rest of the graph look like this.
Yeah, that's our answer.
Note that there is a plateau at x equals 1 because the graph goes from decreasing to decreasing once again. So we can see that reflected in the graph that we drew because there is a flat point on the graph. Now, for this third example, this is a bit different. We can see that we are given the f prime graph, but this f prime graph has some discontinuities. So let's begin by drawing the f prime sign chart. So we know that the graph is positive from negative infinity to x equals -4. Then it becomes negative for the next interval. Then it becomes positive until x equals 2. And then it finally becomes negative again in the next interval. And then it finally turns positive until infinity for the rest of the graph. So therefore, we can see that the graph is first increasing, then decreasing, then increasing, and then decreasing, and then finally increasing again. Now, for the f double prime sign chart, we can see that the graph is first decreasing up until x equals -2. So therefore, we know that the interval is negative. After that, the graph is increasing until x equals 0, making that interval positive. Then the graph decreases up until x equals 2, making that interval negative. And then finally, the graph increases for the rest of the graph, so it is positive. Therefore, we know that the graph is first concave down, then concave up, then concave down, and then finally concave up. Now, let's move on to actually sketching the graph. I've already pre-drawn the points where there are maxima and minima and where the concavity changes. Note that at 2 points on the graph, x equals -2 and at x equals +2, there are discontinuities. In this case, these discontinuities are jumps. Therefore, the f prime graph is not continuous at these points. This is significant because this tells us that the graph of f is also not differentiable because the graph of f prime, or the slope, is not continuous. Therefore, we know that there must be a cusp on the graph of f at those 2 points because the graph is still continuous, but it's not differentiable at that point. And the only thing that we know that fits that description is a cusp. So let's just remind ourselves that those 2 points are cusps by labeling them. Alright, now let's begin actually drawing the graph. So we have to first look at the increasing and decreasing patterns. In this first interval, the graph is increasing, then decreasing, while simultaneously being concave down. So that's what our graph looks like at first. And then at this point, remember that there must be a cusp. So keep that in mind when drawing this next portion, where the graph is concave up and increasing. And we can see that there is a sharp turn at that point. Now, for the next interval, the graph is still increasing, but it changes to concave down. And then there must be a cusp at this point. So the graph is decreasing and concave up. And then finally, increasing and concave up. And that is our answer.